All right, so this lesson is going to be on transformations of functions. And so this first page is what our textbook calls Toolkit Functions. Most likely you remember them as parent functions. And there might be some that you haven't seen before. For example, maybe the cube root function, I'm not sure, and the reciprocal squared. Reciprocal squared is not a super common parent function that you see. Anyway, those are what all the parent functions look like. And so what we can do is take those parent functions and transform them to create new functions by adding, subtracting, multiplying, and using negatives. So, and this is a review lesson, so hopefully you're going to remember a lot of this. But if we want to take a parent function and shift it up, what we would do is add on the outside. So for example, if I wanted to take the quadratic function, x squared, this one right here, and shift it up 2 units, I would just take it and add 2 to it. Great, and then if I want to shift down, I'm going to subtract outside. So I want to take that quadratic graph and shift it down 3. I would just take the quadratic and subtract 3. All right, horizontal, it changes, can be a little confusing because it happens on the inside, and when it happens on the inside, I like to tell my students that the inside lies. So this can be the opposite of what you would think. So if I want to shift to the right, I'm going to subtract on the inside. So subtract is going to go to the right, which is the opposite of what you would think. So if I wanted to take the absolute value function and shift it 3 to the right, then I would do the absolute value and then x minus 3 on the inside. All right, to shift left, I'm going to add on the inside. Right, so the absolute value, I want to go left 4, I would do x plus 4 inside. Right, so to get reflections, you use negatives. So if we want to reflect on the x-axis, it's a negative on the outside. So if I want to take the square root function here and reflect it on the x-axis, so it's down here like that, I would do a negative on the outside. It reflects it on the x. And then if I want to reflect on the y, it's going to be a negative on the inside. And I had a student a long time ago, like she's in her 30s now, that the way she remembered is she called it the yin side. So if the negative was on the yin side, inside y, that's how she remembered it. I still think of that too. So the square root of negative x. We reflect it on the y-axis. Okay, and then to get stretches, you're going to multiply. And so outside and inside tell you if it's vertical or horizontal, and then the size of the number you're multiplying by tells you if it's a stretch or a compression. So if I want a vertical stretch, I am going to multiply outside. So the vertical stuff is always outside. And we need to make sure the number you're multiplying by is greater than 1. All right, so for example, that would be like y equals 3 square root of x. That's going to be a vertical stretch. Okay, and vertical compression is still multiplying outside. But it's going to compress it, it needs to be a small number, a number between 0 and 1. So that would be like y equals 1/3 square root of x. Right, and then again, horizontal is the inside, and don't forget that the inside lies. So to do a horizontal stretch, I am going to multiply, and horizontal is inside. But because the inside lies, a small number is actually going to stretch it horizontally. So that'd be like y equals 0.5x, or the square root of 0.5x. So stretch it, make it wider. And then horizontal compression is still multiplying inside. But because the inside lies, a big number is going to compress, so greater than 1. So that would be like y equals the square root of 2x. Okay. So in this example, there's a lot of them. We are going to identify the parent function and describe the sequences of transformations from f to g. So the parent function, I'm just going to identify by equation. I'm not going to identify by words. You could if you wanted to. It doesn't matter to me, but this one is going to be cubic. So what the parent function is f of x equals x cubed. And what we've done to that x cubed is subtracted 4 from it. And when you subtract 4 on the outside, it's just down 4. This parent is the quadratic, so f of x equals x squared. Okay, so we have 2 transformations. Subtracting 3 on the inside is going to be right 3. Adding 6 on the outside is going to be up 6. For C, the parent function is the square root function. And this one has 3 transformations. The negative on the outside is a reflection on the x-axis. Oh, sorry, there's just 2. And then plus 2 on the inside is going to be left 2. This next one, the parent function is, again, the square root function. This one has 2, reflection on the inside, the y-axis, and then up 5. Okay, E and F are special. I didn't talk about this before, but I probably should have mentioned it. So I have this box up here that has important information that might not have come up in Algebra 2, but it is important. So if x has a coefficient other than 1 and addition or subtraction inside the function, we need to factor out the coefficient. And that happens here. So let's see if I can pull it. Okay, so this one has absolute value of x. So that's the parent function right there. All right, so the transform function, if you're looking at that one, it looks like it's going to have a horizontal compression and shift 6 to the left. But if we actually look at it, the transform function, oh, and there's a reflection. It does have the reflection and the horizontal compression, so it gets skinnier, but it only shifts 3 to the left. And that's because of that 2. The 2 is affecting the shift. So to take care of that, what we'll do is just go ahead and factor 2 out. Not outside of the absolute value, just outside of that expression inside the absolute value. Okay. And so our parent function is f of x equals the absolute value of x. And then from here, you can write down the transformations which is reflection on the x-axis, horizontal compression, and left 3. Right? F has that same situation. Even though it looks kind of weird, we could rewrite this as 2/3 and then negative x plus 4. So this is when the x has a coefficient of -1. We would need to factor out that -1. Okay. So that's going to make us have a vertical compression, reflection on the y, and right 4. So in class, I would have you guys try these last 2 on your own. So pause, if you're watching this at home, pause the video and then see if you can do them on your own. All right. In the last examples, we are writing the function that has these transformations. So we're going to take the parent function that is the absolute value, and we're going to reflect it over the y-axis and horizontally compress by a factor of 1/4. So you have to call it something. We can call it y. I'm going to call it g of x. So now to reflect over the y, you have a negative on the inside or the inside. And horizontally compressed by a factor of 4, we're actually going to need a factor of 1/4. We're actually going to need a 4 there to make sure it gets compressed. So the horizontal compression and shrinks would do the reciprocal when we're writing it. Okay, so this one is going to take the reciprocal squared function, vertically compress it by a factor of 1/3, shift to the left, and then down. So vertically compressed, we just multiply by on the outside by that factor. All right, so we still have the 1, and then we're going to have something squared. All right, so to go to the left, we're going to add on the inside, and to go down, we're going to subtract on the outside. Okay, and then horizontal, take the quadratic horizontal stretch by a factor of 2. So remember, we use the reciprocal on the horizontal stretches and compression. Then right 5 and up 2. Okay, so if I'm horizontally stretching it, I need a 1/2 there. And then I'm going to have to do x minus 5 in its own set of parentheses, so my stretch doesn't affect my shift. Squared on the outside, and then up 1. Okay, so your assignment comes from a lot of pages. I hope it doesn't get too confusing. And I want you to don't worry about sketching. So if the directions say sketch, then just do the describe the transformations instead.